in your syllabus you have 3 things in the science, like chemistry, biology part, and the physics. Today I'm helping you in the physics part, and this is a brief thing about your physics part. I think if you learn this is the first time, it's not to watch this video, because this is a revision, right? If you have learned this before, you can get an idea about again what are the things that you have learned, right? In the content page, basically you have 4 lessons, like energy lessons, you have electricity lesson, you have forces, and you have sounds. And you need to know the sound is a type of energy, right? Sound is a type of energy. Also, a force can be mentioned as a type of energy. And electricity is, that is electrical energy, right? So basically in here you have to discuss about the energy parts, right? And in the each part you have some basic things that you need to know, and some other parts there is nothing to know, like it is some general knowledge lessons. So let's move to the first part about energy. In here, energy and changes, you have some picture, right? This is a children's park, and there is a number of energies that you can see. First of all, you need to the ability of see some energy types, like in the height you can see some object in the height, there is a gravitational potential energy. And if someone is going to move, if someone has velocity, we can say there is a kinetic energy. Also it is rotating, there is a rotational kinetic energy. And there is some lights, right? So you can see there is a light energy, or there is sounds, right? So there is sound energy. Also all the functions are worked by the electricity, so there is a electrical energy. So now you have heard about some energies. That means energy have different types, right? Sound energy, light energy, gravitational potential energy, elastic potential energy, kinetic energy, nuclear energy. There is large number of energies, right? And we have to learn about what are the important facts about the energy. Why do we need to learn about the energy? What is that energy? That is the thing, right? And here you have to see things, right? And energy is used for do something, right? And energy is measured by the joules, right? The symbol is capital J, joules. You need to know about the unit and its symbol. And sometimes you may recall, now you have learned these things before, that is kilojoule. What? So I mentioned unit is joule. So what is kilojoules? You know that kilo, this is simple K. Kilo is mean by the 1000. Kilojoules is used in the food, when we measuring energies about the foods, right? In the foods, because in the deal in the energies about the foods, there is a large numbers. So to easier to use, to easier to use, we use kilojoules, right? So that is not the SI unit. SI unit is this, we use a prefix to deal easily. And if in this lesson you need to know one thing, that is energy conservation law. What is energy conservation law? There is a law about the energy, that is we cannot create or destroy the energy. So energy is a fixed thing, right? You cannot create, you cannot destroy. Sometimes you may think, we can't create electrical energy. Yes, we create, but it's not exact create. That is, we convert it from another type, right? First of all, you may think hydropower plant. This is the water level, and there is a tunnel, and there is a turbine, and here there is a turbine, and there is a wires, and we generate electrical potential energy. kinetic energy, electrical energy. Can you see the transfers? Only we can store and transfer energy. That is energy conservation law. What? Energy cannot be created or destroyed. It can be only converted, only transferred or stored. So energy can be transferred any to any. Automatically it can be, right? Some electrical energy to heat energy in the ions, electrical energy to light energy in the bulb, electrical energy to kinetic energy in the fan, or you can do vice versa. Kinetic energy to the electrical energy, potential energy to the kinetic energy. You can do, right? Now think about a coconut. There is a coconut tree. A coconut is left from the tree. What happened? There is the coconut tree is from the some height from the floor. So there is a potential energy, and it when it leaves the tree, it becomes kinetic energy, right? Those are the transfers that you need to see, right? Let's talk about later. Now you have some basic idea about what is energy, right? First lesson is energy from foods. I have to mention you something. Now I mentioned you about you cannot create, you cannot destroy, but you can transfer it to some energy, change it, or you can store it. When you're going to store it, you have three things. What are the three things? Foods, fuels. What is another thing? Now you need to know. Can you recall? That's cells. In these three times, energy stores as chemical energy. Sometimes you may think cells, in the cells we stored electrical energy. No, we always stored a chemical energy. In the cells there is chemical energy. Cell like ඇතුළේ chemical energy. When we take out in the cell, if this is cell, in there is chemical energy. After it comes out, it converted to the electrical energy. Not inside, it's always outside. You need to know that, right? In this lesson we have to talk about foods. You know that we need foods to live, to repair our body, to keep our warm. You can read these things later. And there is the unit of measuring energy, joule, capital J, right? And to easier we use kilojoules, right? And there is a nutrition information label. You need to refer this, right? Now this bun is 65 gram. To compare these things with other foods, they have converted to the 100 grams, right? So you can see, if in this bun you can take this energy, but if you use 100 grams of this bun, if you eat 100 grams of this bun, you can take this energy. And protein is same. It is protein is energy. You can see energy is measured from the kilojoule, but protein, carbohydrate, fat, fiber, sodium, they are measured from the grams. Why? Because they are from the masses. But energy is not a mass. Energy is a type of mass according to the Albert Einstein, but it's not relevant for here. Energy is measured by joules. In the food, that's kilojoule, right? And there is again, you have nutrient information label, and this burger is 125 gram, but if we need to compare this from another one, there is 100 grams, right? So now you can think, if you need to compare this bun and the burger, you cannot compare this directly because the masses are different, right? The masses are different, so it's unfair. It's unfair, right? So you need to check each values from them, each weight from them, each amount from them. That is the fair one. So that's why this column is important. Now clearly you can see per 100 gram in this bun, it's only give 837 kilojoules, but in here 1592 kilojoules energy, right? Energy is in here, energy is more, this one is more. You can see everyone is more. So I think it's better to eat this food, than this one because it gives us more energy, more carbohydrate, more things. How did I compare? Not using this column, it is unfair because this one is also 125 gram, this is only 65 gram, but I'm using this column to compare, right? And now in the age and the activities, different kind of people get different energies. You can see energy is increasing until the year 18, then age 5, age 11, age 18, their energy requirement is increasing. But in the adults, you can see in the adults they are compared using the activity. If it is normal adult, it's low. Active adults more than, very active adults very high, right? There is a energy required chart you can see, and if they may given in the examination, you may given this type. What is this type of graph? This is a bar graph. You can see in the age 5 how many things, because 400, in here 800. What is the midpoint? It is 600. So age 5 is student, age 5 person need 600. What is the, not joule here, kilojoule, right? Read the axis. Average energy required, not average, not exact one. Age 11 one need how? It's like this one, no? In here you can see it's 10,000. In here you can see it's between 8,000 and 10,000. It's like 9,000, right? It's 9,000 kilojoules. Unit is must. In this one, as I think it's 10,000, it's 11,000, right? Like that you can calculate 12,000, 16,000, right? So there is some facts, you can read things, right? A good balanced diet is provided all the nutrients, because our food needs all the nutrients to repair our body and to growth, no, to keep our body warm, right? And let's learn about it year 8, right? Year 8 first lesson. Right, in here there is some fact. The animal koala, he sleeps over the 20 hours per day because it eats on a eucalyptus leaf that does not give it some enough energy to maintain the day, right? So a lot of day he is sleeping. Sleeping is the activity that we require least number of energy, right? Sleeping, right? And we have the fair comparison and the ratios in here. Fair means in the here basically you have to do dissolve foods, mixed foods with water, and heat them and measure the temperature. Using that temperature you can get idea about how many energy is stored in these foods. So in that practical you need to take each weight, each masses weight should be equal. If you take this 50 gram, this should be get 50 gram too, this should be get 50 gram too. If you get all the 50 gram and this take 1 kilogram, use it. You may think that you are great, but it's unfair. There is method, you can read this. There is apparatus, the things, right? Boiling tube and the thermometer to measure the temperature and the things, and you can read this later. And every boiling tube is inserted only just 10 cm3 water, 10 cubic centimeter water, right? And burn them. Okay. Here you can see the mass of foods are burned is not equal. This is 4, this is 2, this is 4, 4, 1. This is unfair. That's why you need to get additional column to divide them. So it's better to convert all the things to the 1 gram or 4 gram. You can do it any side, it doesn't matter. I like to convert this to the 1 gram. I'll convert, right? If this is 1 gram, it becomes 2 Celsius. If it is 1 gram, this becomes 4 Celsius. If it is 1 gram, this becomes 3.5. Now this is 1 gram, it is also 4.5. Now what is the first place? You can see this is the first place. No, that's not. 4.5 is the first place. This is the first place, this is second place, this is third place, this is fourth place. Now can you see the order has been changed, right? In previous scenario we thought this one gives the most of the energy, but because the masses that we 2 is difference. We have got we have obtained a mistaken conclusion, right? But if we correct the mistake, if you get it as fair, we can get the correct conclusion. Here, if you get some equal masses, you can get the correct conclusion. What is meant by conclusion? Conclusion is the result, the final decision made using evidence. What is evidence? Evidence means this practical, right? We have evidence to prove our result, our decision. That is conclusion, right? Now you can see, if it is unfair, our conclusion is wrong. If we correct that, if we divided it to the same value, we can obtain the exact result, right? In here they have get extra column that temperature rise per gram. That's what I obtain here, right? Using that, in this table, in D table, you can use to get a conclusion, right? That is a basic things that you need to know. And the ratios. Ratio is the simplest form that you can express the things. It's ratio, right? Ratio helps to give you some idea about the amounts, right? It is must to writing the heading temperature rise for 1 gram in bread, it's 2 temperature rise for 1 gram in cheese, and you can keep it 2.4, but it needs to be simplified to 1.2. Please note, ratio should not be in fraction or a decimal. It is in the whole number, but in the simplest form, right? So 1.2 is the ratio. And energy transfers and stores, right? We learn about that we cannot create or destroy the energy. We can store and transfers energy. You have some type of energy: thermal energy, light energy, sound energy, electrical energy, mechanical energy. And there is something that you can store: foods, fuels, cells. Those three things you can store the energy. Here we stored as chemical energy. In our body, we stored as, we take the chemical energy, we don't produce light energy, right? We produce sound energy, kinetic energies, potential energy. Those energies we can produce, right? In the vehicle, chemical energy transfers to the there is mechanism to electrical energy, and it's some complex, but you can get a rough idea, right? In the examination you will not get hard questions, right? Kinetic energy means what? If some object is moving, there is kinetic energy, right? It doesn't matter it's kinetic energy, electrical energy, sound energy, light energy. It's whatever energy. What is the unit? Energy is joule. Only in the foods we measure by the kilojoule. Kilo means 1000, you know that. In the sign, which I think you may know, right? Mega, giga, nano, centi, deci, right? Okay. This is law of conservation energy. I have mentioned it before, and this is it, I think, right? Then thermal energy. If some object is hot, there is a thermal energy. If someone is cool, there is a less thermal energy. And there is one strain energy and the elastic potential energy. What happened if you take some rubber band, if you stretch it, you can obtain, you can store in that one in elastic potential energy, right? Elastic potential energy and gravitational potential is two types. Elastic potential energy happens in the elastic object when you stretch or compress that, but gravitational potential is the energy that is stored when some object go to a height, right? If some object goes to up, there is gravitational potential energy. And nuclear energy or atomic energy, that is now in the modern technology we use nuclear energy to produce electricity. It is it can produce a large number of electricity, but should be maintained very well and needs to be high technology. You may had heard about Chernobyl, right? Nuclear power plant, the disaster, right? If some small mistake can be a good disaster, right? You can see that there is some TV series or something else. After the examination, you can see Chernobyl. Energy is stored in all materials. We know some of the transfer is energy is nuclear power stations. We call this as nuclear energy, right? Okay. Now, can you recall the types of energy? Conservation law of conservation energy. What can we do to energy? What can't we do to energy? And you need to know how to write energy transfer. This is the starting one. This is the ending one. No, right? In here, what are the things that you can see? Exactly, I can see there is a gravitational potential energy, and if it is moving, if it has only a velocity, if it has only speed, only there is a kinetic energy. Otherwise, if it's not moving, there is not a kinetic energy. Then we have to move to fuels. Fuel is a substance that contains of chemical or nuclear energy. There is some nuclear fuels like uranium. Those things are used in the power plants, like those things in nuclear reactions to do. And you can read things, no? And you have about fossil fuels. What are the fossil fuels? Fossil fuels, you have natural gases, oils. Oils means like petrol, diesel, kerosene, those things, and coal. The basic things that you need to know: fossil fuels are made from remains of the organism that died millions years ago. So that means you cannot create this again and again. So fossil fuel is a non-renewable fuels. You may now, can you remember renewable fuels and non-renewable fuels? Right. Coal. Think about coal, oil, and natural gas is the same process. It means both happens in organisms that died millions ago, but coal formed in from it may be in the buried mud which stopped from the rotting away. This can be formed under the earth, inside the earth. It doesn't matter, right? But oil and natural gases is formed under the sea, right? That is the difference between now you can read these things and get an idea, right? Crude oil is a mixture. We separated crude oil into the things, and we can obtain different type of fuels that you know. And renewable fuels and non-renewable fuels. Yes, renewable fuels can be created again and again with our lifespan, but non-renewable fuels take millions of years, hundreds of years. So we cannot create it in our lifespan. That is non-renewable fuels. You can see how can we use oils, gases, coals for future years, right? So we have to save them because we cannot create them again and again, right? Other fuels, we can use some other fuels instead of fossil fuels, because fossil fuels emits lot of carbon dioxide gas and many other poisonous gases, right? It is harmful for the environment. You know that carbon dioxide is a reason for the global warming, right? Let's learn about it at grade 8, year 8, right? Fossil fuels. Biofuels can be made from plants and waste in animals. They are renewable fuels, right? Before some years ago, there is a hype to use about biofuels, right? Now it's silent story. And hydrogen gas is a gas that can be used as a fuel, right? In the European countries, buses and some vehicles are driven using the hydrogen gas, right? Hydrogen gas is a fuel too. Also, your robots use hydrogen gas, and hydrogen gas should be used in carefully, right? And transporting goods. I'm not telling all the things in the lesson. I'm just telling what are the things that you consider about when you transporting goods, right? The time, the type of food, the type of foods, and the routes, and the time means delivery time, right? And the cost, right? If we do some business in the cost, now think about food city chain or key supermarket chain, right? They need to send at the time, and all the foods cannot be transferred at the same time. Some foods need freezers like ice creams, those things. Some foods needs to be more protection, like I mean like eggs, right? So, and the routes, right? If it is Colombo, all the cities are not, if there is now 25 districts, no, there is not 25 trucks for all districts, like there is some routes, one, like they have divided some routes, and there is a manager and they control that uh, cost, and the routes and type of foods, and the delivery time, and the food expiry dates, right? Right, sometimes when it delivered to shops, it not be expired, right? It should be maintained its freshness, right? You can read this lesson and get an idea, and you can become a transport manager, right? Transport managers, right? So then there are some duties to you, right? These are the STEM subjects, I mean STEM careers, right? In the STEM careers you need problem solving skills, and what is another one, communication skills and related knowledge about the things, university degree about the related fields, right? There's common things, right? If it is factory here, you need to transport these things into shops, and there are some routes, you can divide it to 2 or 3 routes to manage them, and you can save the cost, and you can do it efficiently, right? There is a careers in transport goods. Those are the things that you need to pay focus, that you need to focus in this lesson, right? Let's move to next, other energy resources, right? Here biofuels are renewable fuels. Now you know what are the renewable fuels and non-renewable fuels, and for what we use biofuel fuels, for the vehicles, heating, cooking, generating electricity, right? And we use solar power. What is solar power? Solar power used to use energy transferred from the sun. Solar power, right? That is a generic term, solar power. To do that, we use solar panels and solar cells. The both use solar power, right? Solar panels are used to heat the water or heat the building or something like that. Solar cells used to create the energy, right? In now there is some hype to install solar cells, no, because in Sri Lanka we get a lot of sunlight, so that's a better choice. What is the drawback of the solar cell? If it is instant cloud, if it comes instant cloud, right, your electricity is not, you cannot get the electricity as instantly, right? Okay. And there is wind turbine and hydroelectric powers and geothermal powers. Do you know what is geothermal powers? In the now it is the planet, in the mid of the planet there is a high temperature, so you pump water into the under the ground, and you take it as water vapor in high pressure. Then there is a turbine, and you rotate the turbine using that high pressure of the water vapor, right? And in everyone there is a turbine. In wind turbine there is a turbine, hydroelectric power there is a turbine, geothermal power there is a turbine. Rotating a turbine, you can generate the electricity. That is the thing that you what happened. If you have interest about that, you can search in the YouTube how work wind turbines, how work hydroelectric power, how is working geothermal power, right? And the one thing you need to know, that how energy transfers in these things. Wind turbine na kinetic energy converts to electrical energy. Hydroelectric power plant na gravitational potential energy to kinetic energy to the electrical energy, right? Search about, now you have some many things, GPT, Gemini, right? There is many materials you can search about, right? And nuclear energy from the sun. in there you need to know about the photosynthesis process. What is photosynthesis? Photosynthesis is a process that plants generated their foods, right? And they get energy. Sunlight also provides the energy for plants to grow. The energy is needed to photosynthesis. This is the process by which plants make their own food using carbon dioxide. Now, there's two things. Plants are breathe too, right? In the in that process, they take oxygen gas O2 and they emit carbon dioxide gas. This is breathing process. That is one. This is another process, photosynthesis. In the daytime, they do both the photosynthesis. In there, they take carbon dioxide and they emit what? Oxygen gas. Right? Identify there is a two process. Right? In the night time, they cannot photosynthesis because there is no sunlight. So in the night time, they do only breathe. In the daytime, they can do the both. Right? What are the things that need to do photosynthesis process? Sunlight, water and carbon dioxide. Then what they emit? Oxygen and the glucose. You know, glucose is a type of sugar, and there is many things. What are the other sugars like maltose, sucrose, you know, and there is disaccharides too, lactose, galactose, and right. And read these lessons, and you can get an idea. This is just a revision. Right? This is just a brief for you. So I will not cover every single point. This is for just for brief, right? Otherwise you will miss some points, right? Go through with this summary and then go to further more details by reading these lessons. And using resources. Using resources is fossil fuels, nuclear, renewable fuels. That is three type of things. You have advantages, you have disadvantages, right? You can read this and remember these things, right? I'll give you some trick to you. Think about, is renewable or non-renewable fuel. If it is renewable, it goes to the advantage. If it is non-renewable fuel, it goes to the disadvantage, right? You know, these things are non-renewable, these are renewable. And if it is if it is release some gases like polluting gases, it's harmful to environment. So if it's releasing polluting gases, it is disadvantage. If it does not releasing polluting gas, if it is an advantage. And I mentioned before, in the nuclear one, the power stations are very expensive because it's high technology. You and me cannot maintain like that one, right? And there is one producing dangerous waste, right? And fossil fuels is advantage, cheap compared to other resources, and it's convenient to use in cars and other ways, right? Now I hope all the things have been touched, right? You can remember, you can use that trick, right? um, by polluting gases, releasing polluting gases or not, is it renewable or non-renewable fuels, by the technology and the price, right? And availability of all the times and those things, right? And there is a climate change, you can see. And releasing carbon dioxide is not good, right? And we need to reduce the releasing amount of carbon dioxide, right? That's related to carbon footprint and the things, right? Okay. And efficiency. What is efficiency? Efficiency is a way of saying how much of the energy transferred by a machine is useful. So think about here, some you may have seen some oldest light bulbs, like these are yellow color bulb, tungsten bulb, and after we got CFL bulbs. This is a tungsten bulb, CFL bulb. Now we use LED bulbs, right? There is some generations, right? In this first bulb, if it takes 100 joules, it created only 30 joules. This is rough values. All other 70 joules are waste by the thermal energy, converted to the thermal energy, right? Now you can see the 100 joules converted to many joules, right? The left side is equal to right side. This is like 100, the sum of the 30 and 70 is 102. Energy does not destroy it transferred to someone, but only light energy is 30, the rest is 70 is wastage, right? Now in the LED, it's enough to use 35 joules. It's converted 30 joules as light energy, 5 joules as thermal energy, right? Now you can see 35 is tally with the 30 plus 5, and the in here we use 30 joules. In here we can get 30 joules, right? Our output light energy. But in this first bulb we needed 100 joules, but in now we need just 35 joules. So that is a meaning of efficiency, right? Efficiency as a formula, that efficiency equal the useful energy over used energy. Used energy means this one, the 100 and the 35. How many energy that we use to transfer our required energy, used energy, times 100%. You can use this formula, and it is, now think about, we don't need this thermal energy, right? We don't need this thermal energy, right? It's useless. This is not iron. Our job is not, our requirement is not heating. We need just light energy. So it's better to convert it only the light energy. But in the, you know that everything is not 100% efficiency, right? But at least we stop, we need to avoid the wastage of the energy, right? If you use this light bulb, uh, if you use this light bulb, right, your power bill is increased. But if you use this bulb, your power bill is very low cost one. What is the reason? Because the same process, in both one we got the same output, same light, but in here there is a lot of usage, but it's not, right? That is a talk of the efficiency and making changes. I hope you can read this lesson, right? This is a very funny one, right? Now you may everyone has watched the cartoon, right? The Fleeced, right? Giripurattu, right? Like that. In here, you can see there is not electricity, no? They use many funny things to do their works, right? Right. And so now think about what happened if you live a day without electricity, a power cut day, right? You cannot turn a light, you cannot turn your mobile phone after it's battery dead. Think about a week like without electricity. You cannot. Now you may think I have power bank or something else, but after power bank is after some 2 or 3 days it has dead the power too, no? So you cannot operate their phones, you cannot operate their computers, you can operate their tablets, not any electrical items, right? Fans, rice cookers, washing machines, right? You have to wash your clothes by your own hand, right? You have to live in a cool place, right? Right, there is many things that you need to pay attention, right? In the night you need to use some candles or something to take the light, right? Because there is not, you are out of electricity, right? So in the society, electricity is the main part of our life. Now you may think, right, electricity is the main part. Now you have a good idea about the energy, right? Our next lesson is moving to the electricity, right? I hope it's, now you have a good idea about energy, so you can join in the next part to understand what is electricity.